Okay, folks, welcome back. Today, what we're going to be doing is we're going to be looking at how we build ethene using Lewis dots. If you remember, this was the one molecule that we were having trouble with when I was helping you out, and that's because we thought it was actually going to be a lot more complicated, when in reality, it's actually really, really very simple. And I'm going to show you that, and I'm going to keep it simple, okay? This is really, really simple. There is no exceptions, no funky rules or anything like that. It's just the same as what we've done before. But I'm going to show you step by step, okay? So let's begin. Now first off, of course, ethene is C2H4, or we also call it ethylene. Now, we want to consider the Lewis structures of each one of the C's and each one of the H. Whenever you're going to build one of these in its Lewis form, you want to draw them each individually so that you can see what you have to work with. Okay. In this case, we're drawing them with their valence electrons. Hydrogen, of course, each has 1, and carbons have 4. Once we have this, then we ask ourselves, how can we build molecules obeying the octet rule? We start putting them all together any which way. There's no real special way because we try every way and we're going to find there's only one way to put this thing together. If we put the H's together, we'll notice that the H's will fit, but once we put two H's together, we're done. We can't add anything more to this molecule. So we know this is not the way to do it. Okay? This doesn't really help us. If we add a hydrogen to a carbon, okay, hydrogen is full. Carbon, though, is incomplete. Okay? Now, if we add carbon to carbon, carbon is incomplete. But if we look at the last two structures, okay, we're going to notice a few clues as to how we can now build the molecule. We have at least an idea of what's going to work. So let's think about it for a few seconds. And then let's go ahead and build with what makes sense. First off, let's start by adding the hydrogens to each carbon. Okay, that's what we get. And then, that's what we get when we add the second set. But we're not done yet, okay? Remember, okay, we have these two leftover single dots, and we almost will never want to have single dots on our molecules, okay? Single dots are usually a bad thing. You don't want them. So if your molecule has single dots, it's probably incomplete and you have to find a way to fix that. So what we're going to do in this case is we're going to move the single dots from here to here, okay, down to the middle. Once we do that, okay, our finished model is going to look like this. Now, as soon as you look at this, you're going to ask yourself, okay, does it work or did we cheat? Well, let's think about this for a second. If we look at the valences for the hydrogens, the first hydrogen works, and the rest also work. Okay. If we look at the valences for the carbons, the first carbon has 8, as does the other one. So it looks like they all work. Okay. That takes us back to the rules for Lewis structures. Okay. Remember, of course, that when you're drawing abstract elements, okay, abstract elements can have one dot. That's why when we first drew our first set of everything that was available, we drew them with one dot, because that's the way they are in abstract form. Abstract, you know, in your mind, when you're just going to build them. But when you're going to actually build real-world elements or molecules as they would exist in nature, or at least to represent them, you always draw them with two dots. Well, almost always. I mean, so often that you can forget anything else, okay? Why? Because it's more stable. Okay. This, as a matter of fact, is an interesting point because whenever you see many molecules that if you draw them and you see that they have single dots, in nature you will not find them in single form if they exist that way. Almost any time you see any element that has less than its octet, full octet, it's probably going to join with another of itself to form the octet. Okay, you're going to see that in a lot of other. So I'll let you go look but check it out. Okay, now let's move forward, because we always want to come back to that simple rule, which is that Lewis dot structures are based on that octet rule. Now I do know that hydrogens, their shell gets filled with 2, and it sounds like, that's not an octet. Okay, well, it's the only exception, but I include it there. So just yeah, it's not exactly an octet, but I call it that. Okay, so I'm wrong. But the rest, they should have 8 valence electrons. Okay, now there are exceptions to the rules, like the transition elements, some of the lower period elements, the ones that are further down the table. But in reality, you're almost never going to deal with them. You will hear about them. You will occasionally hear about them when they're well behaved, but you're usually never going to deal with. You're almost never going to deal with them in their more exceptional forms. So you can pretty much ignore that for now. We will deal with it a little bit, not much. Okay. Again, remember, when you're counting all the dots, when you're counting valence electrons, count all the dots. Okay. In the example that I previously gave you, I showed you that carbon has 8 dots when you count it that way. Okay. Don't overcomplicate it. Okay. You're only counting the ones that are around the atom. You're not reaching out to count others. So in this case, when we do this, it has 8 valence electrons. Okay. If we look at hydrogen, hydrogen in this case has 2 valence electrons. Okay. The rules, again, they are simple, simple, simple. Okay. If you keep that in mind, if you're given another molecule, in this example, C2H4, just let the octet rule guide you. Okay. If you have lone dots left over, make double bonds or even triple bonds. Whatever you need to do to pair up those lone dots. Okay. You do not want to have lone dots. Okay. I'll give you a final example, just so we can see if we figure this out. Okay. We're given a molecular formula so that we know what to work with. This time it's ethene or ethine, which is otherwise known as acetylene. If we lay out the pieces, we get this. When we build the molecule, we get this. But we got to fix the lone dots. When we do, we notice we still have lone dots. So we're going to fix that. And that should give us our finished molecule. Now notice that all atoms here satisfy the 2 or 8 electron octet rule. Okay. It's important that you pay attention to this. I'm going by this really quick. I expect you to stop this video and look at this and reason it in your head. You're not going to be able to visualize this the first or second or third time you see this. It's just not natural. That's why you want to continue to do it and continue to do it, and you're going to notice this. Something else you're going to want to notice about this molecule. Okay, the 3 sets of double dots actually indicate that this is a triple bond. If you think about it, look at the C and the H over there. That's a single bond. If you think about it, it should make sense if you reason it. Even though, like I said, you may not be able to visualize it, but you'll at least be able to reason it. You do it enough, and you will start visualizing it, though. So that's why I want you to keep doing it. Again, let me go ahead and repeat this. Go back and view this video again. And while you're doing it, make sure and write the formulas down. Don't just watch. If you're just watching the video and not writing anything down, you're only getting 20 to 25% of the value of this video. That's not good. Go back and write it. Write it, write it, write it. Make your learning active. Don't just keep it passive. Make it active. Write it down. Okay? So, with that in mind, I'm going to leave you guys with a few exercises. Hopefully, you'll come back, when we come back and meet, you'll show me what these look like. Okay? Okay then. I'll see you later. Take care.